Alright, just want to cover in this video what I referred to in the last one on solving inequalities, which is there is a slight quirk with them. There's one way in which they're slightly different from solving equations. Okay, I'm going to illustrate it here just by way of an example before we get into actually solving inequalities. So people will hopefully agree that 6 is less than 18. Alright, what happens if I divide across by 3? So divide both sides of that inequality by 3. Well, 6 divided by 3 is 2, is less than. 18 divided by 3 is 6. So is that still true? Is 2 less than 6? Yes, it is. Okay, so my original one is true, it's correct. And after I divide both sides by 3, it's still correct. And that's what I've been doing already when I've been solving equations. I've been dividing both sides by the same thing. Okay, and just like in an equation, you can do that and the thing still holds. What if I divide across by minus 3? 6 divided by minus 3. So go back to the original one here. 6 divided by minus 3 is minus 2. Is less than. 18 divided by minus 3 is minus 6. Is minus 2 less than minus 6? No, it's not. Minus 2 is greater than minus 6. Minus 2 is to the right of minus 6 on a number line. It's greater than minus 6. So this isn't true anymore. So when I divide both sides by a positive, that's fine. Okay, your inequality will still hold. When you divide both sides of an inequality by a negative number, it's not true anymore. Okay. What can I do to keep this true, to keep this inequality, make sure it still holds? You flip the inequality. So 6 divided by minus 3 is minus 2. 18 divided by minus 3 is minus 6. And then you just need to remember that when you divide across by a negative number, you need to flip the inequality around. So this less than sign is going to become a greater than sign. Is minus 2 greater than minus 6? Yes, it is. Okay, so that's the slight difference with these compared to equations. So it is just when I am dividing across by a negative number, I need to flip the inequality when I do that. Okay, so I'll just solve a couple here, and then I will solve and graph one up here. So solve minus 2 is less than 6. All right, so whenever I'm asked to solve something, I want just x on its own. Okay, I don't want minus x is equal to something or less than something. I want just x on its own. So I'm going to need to divide both sides by minus 2 here. Okay, if I just want x on the left hand side, I need to divide that side by minus 2. That gives me x. I need to divide the right hand side by minus 2. 6 divided by minus 2 is minus 3, and then because I divided both sides by a negative number, I need to flip that inequality, and a less than or equal to is going to become a greater than or equal to. So my solution for that inequality is x is greater than or equal to minus 3. All right, let's just test it quickly just to kind of prove to ourselves this is true. So I'm saying this inequality is true when x is greater than or equal to minus 3. So let's get a number which is greater than or equal to minus 3. So let's say minus 1. So if I sub minus 1 in here, I'd have minus 2 times minus 1 is less than or equal to 6. Minus 2 times minus 1 is 2. Is 2 less than or equal to 6? Yes, it is. Okay, so minus 1 is greater than or equal to minus 3. So it is a solution to this. When I sub it into my original inequality, I get something that's true. What about a number which is not greater than or equal to minus 3? Let's say minus 5. What would happen if I sub minus 5 into that original thing? So minus 2 times minus 5. Is that less than or equal to x? Minus 2 times minus 5 is 10. Is 10 less than or equal to 6? No, it's not. It's greater than. All right, so that's how the solutions to these work. Okay, you can test them. If you put in something which is greater than minus 3, you should get something that's true. If you put in something which is not greater than minus 3, you should get something that is false. And that's what happened here. Okay, and that shows that flipping the inequality was the right thing to do as well. You don't need to do this testing of the answer out here. That's just kind of illustrating that it works. Okay, so that's you done if you got that question. Next one here, minus 3y minus 4 is greater than 8. So first thing I'm going to do here is bring the minus 4 over. If you bring a minus 4 over, it becomes plus 4. So minus 3y is greater than 8 plus 4. So just remember, bringing a minus 4 over becomes plus 4. You don't have to flip the inequality for that. It is only when you divide both sides by a negative number. Okay, so it's when you divide across by a negative number that you flip the inequality. Just bringing a negative number over like that, bringing minus 4 over and it becoming plus 4. Nope, you don't need to flip it. So I get minus 3y is greater than 12. To solve this then, I just want y, so I need to divide both sides by minus 3. So minus 3y divided by minus 3 is y. 12 divided by minus 3 is minus 4. And then that greater than sign needs to be flipped. Because you have divided both sides by a negative number by minus 3, that greater than needs to become a less than. And there's your solution for that one. All right. So, and again, I could do that test here if I wanted. So over here, just the full one, kind of where I'm asked to solve and graph one of these. So it's like the other examples I've done in the other video. It's the same inequality 3 times. I'm just asked to graph it in 3 different number sets. So I only need to solve it once. So my inequality that I'm solving is minus 4x minus 3 is less than or equal to 9. So first thing to do is bring the minus 3 over. So minus 4x is less than or equal to 9. Minus 3 becomes plus 3. Remember, just bringing a negative number over, don't need to flip the inequality. So minus 4x is less than or equal to 9 plus 3 is 12. Now I've got minus 4x is less than or equal to 12. So divide both sides by minus 4. And I get x. 12, no, I'll do 12 over minus 4. And then because you're dividing by a negative number, you need to flip the inequality. So your less than or equal to becomes a greater than or equal to. So x is greater than or equal to 12 divided by minus 4 is minus 3. There's your solution. Okay, so this is just something you need to remember when inequalities like this comes up, that if you're dividing across by a negative, you need to flip the inequality. It's a really easy thing to forget to do, so just an alarm bell should go off in your head when you get one of these questions to do. Graphing this then, so I solved this, I got x is greater than minus 3, so I'm graphing it into 3 systems. It's minus 3, so when I drew my number lines, I went down as far as minus 5 and I went up into plus 2. So just make sure you put a couple of positive ones on if you get a negative number, and just go down a couple of numbers from it to minus 5 in this case. Okay. If this had been, say, plus 3, I would have went up to plus 5 and down to minus 2, just to kind of give me that range of numbers to show my answer on. Now, I'm looking for natural numbers which are greater than or equal to minus 3. So it's none of the negative numbers, because natural numbers is only positive whole numbers. So it's 1, it's 2, and then it's greater than, so 3, 4, 5, 6, they'll be included. So you need to just mark in the arrow as well to show you know that continues to plus infinity. Integers then, so what integers are greater than or equal to minus 3? So it's or equal to minus 3, so it includes minus 3. It's integers, so it includes negative whole numbers, so it includes minus 3, includes minus 2, includes minus 1, includes 0, still includes 1, still includes 2. It's greater than or equal to, so we fill in the arrow like that. For real numbers then, so real numbers which are greater than or equal to minus 3. So the or equal to means I put a dot on the minus 3, and then it's real numbers, so it's all numbers to the right of that. So I'm going to mark those on. So I'm just going to fill in the actual line, because it includes all the fractions and decimals between the whole numbers because it's real numbers, and then again continues to plus infinity, so I'm going to put the arrow in. If it didn't have the or equal to, if it was just greater than -3, it would be the hollow circle on -3 to show it never actually reaches -3. Grand. So that's that one done. What I'm just going to do is two things. One, I'm just going to show you how to check an answer again for this one, and also a way to avoid having to do this. So first thing is just checking it. So x is greater than or equal to -3. That's my solution set. So what's a number which is greater than or equal to -3? I don't know, +1. So if I sub +1 into my original inequality, it should give me a true statement. So -4 times x, so I'm subbing 1 in for x. So -4 times 1, -3 is less than or equal to 9. -4 times 1 is -4, -3 is less than or equal to 9. -4 minus 3 is -7. Is -7 less than or equal to 9? Yes, it is. Okay. What if I put a number in which is less than -3? So my solution set is greater than or equal to -3. So what if I put a number in which is less than, if I put -4 in? So -4 times x, so -4 times -4, -3 is less than or equal to 9. -4 times -4 is 16. -3 is less than or equal to 9. 16 minus 3 is 13. Is 13 less than or equal to 9? No, it's not, but that's what I'd expect, okay? Because the number I subbed in was not greater than or equal to -3. So I would expect it to not work with the original one, all right? What I might just do quickly is actually I'll put in -3, okay? Just to kind of show you what happens there. So what if I put in -3? So -4 times x, -4 times -3. -3 is less than or equal to 9. -4 times -3 is 12. -3 is less than or equal to 9. 12 minus 3 is 9. Is 9 less than or equal to 9? Yes, it is, okay, because it's or equal to. Okay, so you actually sub in the or equal to, you should get an equation. Okay, you should get 9 equals 9. All right, so look, if you sub anything in greater than -3, -2, -1, 0, 1, 2, 3, 4, etc., you should get an inequality which is true, which holds. If you sub in anything which is less than -3, so -4, -5, etc., you should get something which is not true. Okay, just how to deal with it so I don't have to divide across by a negative number. So if I kind of start with this, if instead of, so I'll just write it out again, -4x minus 3 is less than or equal to 9. Instead of leaving the x on the left hand side, I could move my x's to the right hand side to make them positive. Okay, so I'm leaving the -3 where it is here. I'm moving the 9 over, so it becomes -9 is less than or equal to, if you bring -4x over, it becomes +4x. Okay, so you're just moving a negative number over to become a positive number. That doesn't mean you need to flip the inequality. So it's when you divide across, you need to flip it. -3 minus 9 is -12 is less than or equal to 4x. I just want x on its own. So I'm going to divide across by 4. So I get -3 is less than or equal to x. Okay, and it's the other way around, but they say the same thing. Okay, so again, I would have mentioned in the very first video that it helps sometimes be able to read these from right to left. X is greater than or equal to -3. X is greater than or equal to -3. Okay, so I was able to get around having to remember to flip the inequality just by moving the x so that it's positive. Okay, look, it's something you need to remember to do anyway, so I'm not sure if it is particularly helpful as a trick, but maybe if you have the choice in some questions whether or not to move So say this was one I did in a previous video. I had B's on both sides and I had numbers on both sides. So there you have a choice whether to move your letters to one side or the other. So maybe move them to the side where they're positive to make the question a little bit easier for yourself. Okay, so that's just dividing across by negative numbers and you having to remember to flip the inequality.